Hello everyone, let's solve some logarithms. So this can be a little trickier. There's sort of two ways that we're going to do these problems. It depends if you're starting with an exponent and then you're going to use logs, or the other way things can go is you start with logs and you're going to go to exponents. So the first one here, what I'm going to do is I'm going to try and talk about it as doing the same thing to both sides, but there are other ways to thinking about this. Here's how I'm going to talk about it. If you see a base 3 exponent and you want to undo that, we are going to take a base 3 logarithm. And if you do it on one side, you got to do it on both sides. So I have the base 3 log of this and the base 3 log of 7 on the right side. Now remember, one of the rules that we know about logarithms is that if you have an exponent, you can bring that out front. And that's when we say bring down the exponent. So what I'm going to do is bring that x plus 2 down, and now I have the base 3 log of 3, which equals the base 3 log of 7. So first thing I do is take the log of both sides, and then I use my exponent rule to bring that log or that exponent out front. The reason that helps you is because right here, the base 3 log of 3, that's 1. 3 to the first is 3. So this equals 1, which means really I just have x plus 2 equals the base 3 log of 7. And if I were to get x by itself, then I will say negative 2. Subtract 2 on both sides, plus the base 3 log of 7. Now, to get that actual decimal, because it says 4 decimal places, we need to use our calculator, and we need to know how to do the log base button. So I'm going to go to math, and I'm going to come down here. I think actually if I go up, I can see log base right there. So in my calculator, I have the log base button. I'm going to say the log base 3 of 7, and I'll subtract 2, and I get negative 0.2288. So x equals negative 0.2288. That's 4 decimals. Now, my suggestion for these is to always check your answers. And I can show you how to do that using your calculator. If you have this decimal and you want to check your answer, use the store button and store it. I always use A, so alpha A. And what I'm going to do is plug that back in. 3 to the power of A plus 2. So if I plug this in, I should get 7. And when I plug it in, I get 7. So I know I did it right. It's really easy to make one little mistake, so I think it's important that you check your work. Let's try another one. In this problem, the exponent is not by itself, so before I do the log of both sides, I'm going to divide. I'm going to divide both sides by 8, and now I have 20 over 8, which I can reduce to 5 halves. It doesn't really matter, it's 2.5. Now I have a base e exponent, so I will take the natural log of both sides, because that's a base e logarithm. And when you do that, this 2x can come out front. So now I have 2x times the natural log of e equals the natural log of 5 halves. And remember, the natural log of e to the what is e? That's 1. So this is just 2x. And on the right side, I have the natural log of 5 halves. So to get x by itself, I will divide by 2. And I have the natural log of 5 halves divided by 2, which I need my calculator for. So I will take my calculator and I will say the natural log of 5 halves divided by 2 is 0.4581. 0.4581 decimals. Now, I'm going to check it again. I'm not going to probably check all of them, but I will check this first couple. 8 e to the 2a is 20. So I know I did it right. Sweet. But the goal is to get the exponent by itself so that you can then take the log of both sides. So let's try a couple more. First thing I need to do is isolate that exponent. So I will subtract 4 on both sides. 8 minus 4 is 4. Now I will take the base 3 log of both sides. And on the left side, you'll bring down the log, or the exponent rather, and then you'll hopefully realize that then that log is going to go away because the base 3 log of 3 is 1. So on the left side I have 5x, and on the right side I have the base 3 log of 4. So to get x by itself, I will divide the base 3 log of 4 5, and that's calculator work. So let me use, if you don't have one of these calculators, the other way that you can type this in is, instead of saying the base 3 log of 4, you can use the log base button, or the conversion, and just do this. The log of 4 divided by 3 is the same thing, and I'll show you on your calculator. If you do the log of 4 divided by the log of 3, this is called the change of base formula. That's the same as the base 3 log of 4. Those are the same thing. So if you don't have a log base button, you do the log of the argument divided by the log of the base, and it gets you the same thing. But I need to take that, and I need to divide it by 5, so I'll take it divided by 5 and get 0.2524. So x equals 0.2524. Okay, let's do one more like that. Now, the last one, this is the trickiest one because they have two different bases. So it doesn't matter which one you pick. If you want to get rid of this guy or the base 4, I tend to pick the one that looks easier. So I tend to pick base 5. So let me see if I try that. Base 5 log of both sides equals the base 5 log of 4 to the x plus 1. So what that does for me is now I can bring this x down, and I have the base 5 log of 5, which is 1, and I'll bring this x plus 1 down and get the base 5 log of 4. So on the left side I have x, and on the right side I have this. So x plus 1 times the base 5 log of 4. Now the trick to this is you have to distribute. I think I probably could have done this better had I gone the other way, but I'm going to finish it now. X equals, when I distribute, I have x times the base 5 log of 4 plus 1 times the base 5 log of 4. Now, the trick to this here is that this is a decimal. So you got to realize that on the left side you have 1x, and on the right side I'm going to subtract this on both sides. So that is the base 5 log of 4. If you have 1x on the left and you subtract this many x's, then you will end up with 0.1387 x's. 0.1387x equals the base 5 log of 4. Which means to get x by itself, I need to divide. So I'm going to take the base 5 log of 4 and divide by this decimal, 0.1386, and I get 6.2126. X equals 6.2126. Now I'm definitely going to check that one because it's messy, and that's about as tricky as they get. So now I'll try and check it. 5 to the a on the left side. That's not to the power of a. On the left side I get that, and on the right side I get 4 to the power. Hopefully I get the same thing. 21,000. Hey, we did it. Sweet. Now it's a little bit off because the calculator, it did round a little bit right here, but there are ways to get it exactly perfect using the store function. So 21998.764. Now, there are some practice problems here. I'm going to leave these for you. However, they are worked out on Schoology, and you should complete them and check them. I want to do the going the other way, and then you can do those practice problems as well. So, to go from a log to an exponent, you also have to use your rules, but you may need to combine the logarithms before you can rewrite it. So in this problem, the first thing I'm going to do is subtract 4. And what I will then have is 3 times the log of 2x equals 16 minus 4 is 12. I don't have the log by itself yet, so I'll divide both sides by 3. That means the log of 2x equals, if you divide by 3, 12 divided by 3 is 4. And now I can rewrite this as an exponent. But you have to know, if there is no log base written, then it is implied to be 10. That's the common log. 10 to the 4th equals 2x. 10 to the 4th equals 2x. 10 to the 4th is a 1 with 4 zeros. So when you cut that in half, half of 10,000 is 5,000. So this guy equals 5,000. Let's try another one. Natural log is base e. So e to the 1st equals 2 plus x. Well, to get x by itself, you subtract 2. So e to the first minus 2 will give you x. I need a calculator. So I'll get my calculator out and I'll say e to the first minus 2. And for the second one, I get 0.3679. 0.3679. X equals 0.3679. Now, if you want to check that, it's easy to do. Oh, wait a minute. Oh, okay, hold on. I typed that in wrong. E to the first, didn't lower it down, minus 2 is 0.7183. You got to make sure you type it in right. X equals 0.7183. So what I did there was I didn't type in, or I didn't hit the over key, so it did, this essentially is e to the negative first, which is not what I want. I want e to the first, minus 2, so 0.783. I will check that one. So store it as a, and then I will take the natural log of 2 plus a, and hopefully I get 1. So I know I did it right. Now, sometimes you have to condense your logs first, so you notice there's 3 different logs in this problem. Let's do a couple things. The first thing I'm going to do is put this exponent back in there because I want them to all be condensed. And on the right side, I'll say this is the log of, well, remember, addition condenses into multiplication, so I'm going to condense this into multiplication, 3x minus 4. So I'll put these guys together. Now it's one logarithm, but they are being multiplied 2 times 3x minus 4. Now if you have the base 10 log on both sides, look, it's the base 10 log on the left and it's the base 10 log on the right. This is where you can just say, well, what if I just didn't take the log of both sides? Then I would have this. Since it's the same base on both sides, I can just write it like this and say, well, that's 6x minus 8. And then I can subtract 6x and add 8 to both sides. And then I can factor. The numbers that multiply to 8 and add to negative 6 are negative 4 and negative 2. Since it's 1x squared, you can just kind of do it in your head. And that means x either equals 4 or x equals 2. Now, you do need to check to make sure that you're not taking the log of a negative number. And if you plug 4 in, you'll take the log of 4 or the log of 3 times 4 is 12 minus 4. So that's going to be positive as well. Same thing here. 2 times 3 is 6. 6 minus 4 is 2. You need to make sure that you don't ever take the log of a negative number because that's not the domain of logarithms. If you look at the graph, you can see why. But once I've got my answers, there are 2 of them. It could be 4 or it could be positive 2. And again, you can check that pretty easily if you plug it in. Last one is pretty easy because it's already isolated. We're saying 3 to the 4th equals 3x plus 9. 3 to the 4th, 3, 9, 27, that's 81. 81 equals 3x plus 9. That means 72 equals 3x, which means x equals 24. So you can take the logarithm, condense it, and then rewrite it as an exponent. Or sometimes you have to get the log by itself. But at the end of the day, it just comes down to, can you rewrite the logarithm as an exponent? So you have some practice problems you should work through. Go through those, check the key on Schoology, and also hit that like and subscribe button.